When an enterprise grows to include branch offices, e-commerce services, or global operations, a single LAN is no longer sufficient to meet its business requirements. Wide Area Network, or WAN access, becomes essential. This video will overview what a network professional should understand to select WAN technologies, services, and devices which will meet the changing business requirements of an evolving enterprise. A WAN is a data communications network that operates beyond the geographical scope of a LAN. The three major characteristics of WANs are: they generally connect devices that are separated by a broader geographical area than can be served by a LAN. They use the services of common carriers such as telephone companies, cable companies, satellite systems, and network providers. And finally, WANs use serial connections of various types to provide access to bandwidth over large geographical areas. WAN access standards typically describe both physical layer delivery methods and data link layer requirements, including physical addressing, flow control, and encapsulation. The WAN access physical layer describes the physical connection between the company network and the service provider network. Terminology commonly used to describe physical WAN connections include customer premises equipment, or CPE, which are the devices and wiring on the subscriber side of the demarcation point. The demarcation point is the cabling junction box that connects the CPE to the service provider. The local loop is the actual cable that connects the CPE to the central office of the service provider. The central office, or CO, is a local service provider of long-haul, all-digital fiber optic communication lines through a system of switches and other equipment. Finally, the data terminal equipment, or DTE, is customer-side equipment that puts data onto the WAN. It accomplishes this via a connection to the data circuit termination equipment, or DCE device, such as a modem, that connects the customer to the WAN cloud. Examples of WAN devices include modems, routers, access servers, channel service unit data service units, or CSU DSUs, and WAN switches. Details about each of these devices will be covered as you continue to study WAN access and technologies. In addition to physical layer devices, WANs require data link layer protocols to establish the link across the communication line from the sending to the receiving device. Data link layer protocols define how the data is encapsulated for transmission to remote sites and the mechanisms for transferring the resulting frames. A variety of different technologies such as Cisco HDLC, PPP, Frame Relay, ATM, X.25, and ISDN are used. Data from the network layer is passed to the data link layer for delivery on a physical link, which is normally point-to-point on a WAN connection. Network administrators need to know the advantages and disadvantages to each option. Be aware not every option is available in every part of the world. Sometimes, as a networking professional, you will have to make the best choice for WAN access based on limited options. The data link layer builds a frame around the network layer data so that the necessary checks and controls can be applied. This is an example of an HDLC frame, but each WAN connection type uses a Layer 2 protocol to encapsulate a packet while it is crossing the WAN link. Each of the serial interfaces on the router must be configured based on the choice of WAN technology and equipment used. Many options for implementing WAN solutions are available. They differ in technology, speed, and cost. Familiarity with these technologies is an important part of network design and evaluation. WAN connections can be over private infrastructure or over public infrastructure such as the Internet. Private options include dedicated and switched communication links. Public connections use the global Internet infrastructure such as broadband services, DSL, cable modem, or broadband wireless. Each type of WAN connection has advantages and disadvantages. You need to know if you are connecting to local branches within the same city, to business partners, to customers, or a combination of these. You also need to consider the geographic scope, regional, national, or international. Finally, you should consider the type and volume of traffic your business will generate. For example, if your company is providing voice over IP, then your WAN technology choice will have requirements for quality of service and low latency. We cannot cover all the details in this short video, but you should develop a comprehensive understanding of these different technologies. Doing so will help you prepare to choose and implement a WAN that works for your organization. Good luck.